to another day. I was so afraid till you came and saved me.
Welcome back to the last part of testing. We'll continue with types of tests. As usual, I'll start this with a metaphor. So I'll start this with the pyramid metaphor along with personal life experiences metaphor that allow us to understand it faster. So think of this as a pyramid metaphor. Component test. Um, Here in component test, you have test doubles, which is pies here, test stubs, and mock test. So before we get into the complexity of that, I want you to think of that as here. So don't mind this end-to-end test. Revert this unit test and put it at the bottom. So those test doubles at the end is your foundation. So imagine as uh, a pyramid needs to be tested in isolation first before we put that in brick by brick because our goal is to create a pyramid that withstand the test of time. Those isolation are tested. We call that unit test, just like this component test. And so the SPY test double, so those are test doubles. We're trying to perfect the isolated brick, right? To make it seamlessly integrated on the brick itself or on the pyramid. Now, think of test doubles as like simulating the real world experience. So unit test, as we know, is just testing it in isolation. It doesn't really test real life um, scaffolding with mortar. So think of scaffolding with mortar as like the dependencies. So our app could be requesting some information to a weather service. So that's where SPY came. So SPY test actually is like putting an inspector in pyramid in the construction of pyramid, and that is, inspector does not interrupt when mistakes happen. They just dug it. So it's like SPY is just is like that. Here it just records the log of the request to the weather service. It doesn't really check the external service. And then for the test tab, it's like an architect that provides a prefabricated stone or materials to create the pyramid. So that prefabricated materials will return a result. So it simulates the real world experience. It's like putting a dependency or the scaffolding needed in the real world to make sure that this unit test, once done, is integrated seamlessly with the uh, pyramid. So that's the test tab. Here, it's a mock test. So this test double or mock test is while spy test just logs the error of the constructor or the construction worker, it intercepts the construction worker. So that's what it does. Now let's continue. With that in mind, we'll continue with the introduction of different type of tests. Component test, also referred as module test, it's testing of individual components. Integration test. Uh, Integration test is like in the pyramid, you're trying to combine different unit tests. So that's where the real world issue. It's like another metaphor is that it's one thing to develop your skills via reading, taking courses, but it's another thing to actually create project from end to end. Can you actually create that in the real world? Because real world simulation requires different skill set. It requires managing your time, creating the actual code, not just reading or um, managing your time. It's combination of those different skill sets. So that's integration test, end-to-end test, also known as functional test. It it's sometimes called browser test. These tests go one step further than integration testing. Test the entire application from front end to back end and database, among other things. So it simulates user action just like a metaphor for your learning or skills. You The real test is like managing a project. Can you handle people that would handle project from end to end and actually serve value? How would you integrate different concepts from different disciplines, whether it's from fraud analysis, business, uh, software development, etc. So that's end to end test. Compatibility test. So it's like, how would you adapt to a different programming language or to a new country? Or how would you switch career, right? So that's a compatibility test. Would you be compatible in different environments? Performance test. A basic distinction is made between several performance tests. The so can you handle tests under pressure? So that's like a performance test. This simplest form is called a load test, in which placed under examples include a high number of concurrent users performing interactions or sending high number of HTTP requests. So that's load test. Sending HTTP, multiple HTTP requests. Another type is stress test. So it tests it in extreme workloads. So not just multiple HTTP requests, but how about performing high level operations like getting something on the database while doing simultaneously high CPU tasks. So those are performance tests. So security tests, we will discuss that in the next chapters. Third topic for this video, test-driven development, where automated testing is included as an integral part of the development process. This development is referred to as TDD. So here, here's the TDD workflow. You first write the test, execute the test, implement the functionality, execute again, and then refactor. Structure of component. Let's first look how component tests, more commonly unit test, is structured. Consists of one or more test cases that can be combined in test suites. So a unit test can be combined further into test suite. Within a test case, you formulate the requirements for the component to be implemented using what are called assertions. So remember, the requirement is like assertions. So just like well life live pyramid. So the first thing you need to do is to begin at the end. So the end is like the requirements or your assertions, the life well lived based on your preference, test-driven development based on components. So TDD is an iterative approach in which you gradually implement the required functionality and secure it step through test. So just like step double, guys, we implement the unit test or each individual component in isolation before we integrate it as a whole. So that's how we write the test. Since the execution of unit test So this TDD is actually another thing is it's commonly used in agile environment. So it's used to create or extreme programming to create it based on user requirements. So it's an iterative approach. Basically, running tests, it's like a business approach to things where you check first the demand for a product before you create it. So just like a TDD. Since the execution of unit tests is often visually supported by tools and field tests is represented by the color red, this step of the iteration is also called red or fail for short. So here, execution, you set up and then you run the test. So red for failure and then green for good enough. Implementing the functionality. In the next step, you implement the component with the goal of meeting the requirements of the test so that it changes from red to green. So while you're implementing it, the test double, you're trying to get it from red to green, running the test again. You can verify that you have implemented the requirements correctly by running the test once again. Not until the test has passed can you move on to the next step. If, on the other hand, the test still fails, you must adjust the implementation accordingly and then repeat the test attempt. So you're gonna run the test again to perfect it in isolation and then refactor. In the next step of iteration, you have the opportunity to improve or optimize code for component. For example, to remove duplicates in the code by rerunning the test. You can always ensure that component continues to implement requirements correctly and that you do not make things worse. So just like test double or an architect putting an inspector or prefabricated materials, you're trying to check first if it seamlessly integrate before you integrate it on the full code, uh, so that you don't improve other parts of the code without making sure that that code that you did is actually the the right component or the material that will help the pyramid withstand the test of time. A component that's being tested is also referred to as a system under test. So here, system under step setup, exercise, verify, peer down. Uh, Structure of individual test cases. So that's the structure of individual test cases. Setup phase. In this phase, a specified initial state is first initialized for component under test. For example, a specific structure of an object structure that is to serve as a parameter for a function. So a structure of an object that will serve as a parameter for a function, that's the setup phase. So we set up the object structure. So here's the example for that here, cons contact managers. This object set up our object structure, first name, last name, email, and then execute. So here's how we execute. So execute exercise phase. The code for the setup is phase followed with the code to be tested. For example, you would call a function or method to be tested now. So here, await contacts manager that add contact. So we get this add contact function in contacts manager in the previous videos. We just import that because this contacts manager does not persist something on database. It only persists it in memory. So it's a good exercise because remember, testing or test double doesn't, especially unit test or the foundation, doesn't interact with the real world or the database because in database or in end-to-end test, you actually integrate it with the database. So here, await, remember that's how we call it, the function await. Contacts manager dot add contact. So import contacts manager first. So here's the structure of that folder. Contacts.manager, node modules, package.json. I'll show you guys how to create that in your folder later. Verify in the subsequent phase, you use the assertion mentioned earlier to check whether the real result of the tested component correspond to the expected result. For example, whether the return value of a tested function correspond to the expected value. Here, you verify calls number of contacts underscore that size, expect number of contacts to be 1. So here is actually how we do that. As you can see, guys, I made mistake in creating, which actually how that's how you learn. So don't be afraid to make mistakes. Here, first, what I did wrong, I'll show you what I did wrong is that I create a folder and I enter npm install. So what should I have done is I run npm init, okay, when you create the folder. So you run npm init and then it will create the package.json and then package.json. So remember package.json. Here I made a mistake, 28 failed, 1 passed because I haven't actually run npm install and I don't have the jest yet. So I npm install get child item force. So as you can see, I don't have node underscore module, so I install that just specifically because sometimes like npm install won't install it. So after I install it, when I run, this is how you run test, guys. Npx just. So as you can see, 1 pass, 1 total. There's no 28 failed anymore. So collect coverage, we'll discuss that later. Tier down, similar to the setup phase in which you can perform initial configuration work. In the tier down, you have the option of performing cleanup work, for example, disconnecting database, deleting data. So we don't have a tier down phase here. Running automated tests in JavaScript, preparing, so that's how we prepare. We just need to do this, guys. I think if you don't know how to do this, I mean, I would suggest you to go back to the previous videos because I have discussed this extensively. So if not, it's gonna be serve as an exercise for you guys. So just create this folder structure. Here's my folder structure, contacts manager. Here, coverage. So when you use this npx just under dash dash collects coverage, it will create this folder to this directory. And this directory will have HTML that will allow you to see it in the browser. So if you do not know coverage is like an end-to-end test for our code. So it will test all of our codes. First, accountability is included using via require. You can do best using function test. The test function is implicitly when it takes. So it's just a iteration of this. Require, it's like an import, and then test. So here, in our test, helper function test. So it's a helper function by just. The test function is implicitly when so it's the test function in Jest is immediately available if we describe it using this syntax test. So the function is giving as the first it's a select the test itself as the second parameter in the form of a function. So the second parameter is the test itself here, async. So this is actually the entire function, this second parameter. And then await here, and then setup, execute, verify, tier down. In the setup phase, we create an object instance of context manager as well as contact object. In the execute phase, we call the add contact method to be tested, passing the contact object. So we call the add contact here in the execute from this contacts manager, this add contacts. Remember that. In the subsequent verify phase, we use expect function. So expect function is a syntax by just to verify exactly one contact is in the contact list. This function is also a helper function of just, which you can use ensure exactly such requirements assertion via what are called matchers. So we ensure the assertions requirement as are fulfilled via what are called matchers in jest. Okay, assertions, matchers. The to be matcher used in this example checks in this case whether the number of contacts variable has exactly the value 1. If that's not the value, the script will fail. So here, the to be is another helper function of just. So it used to check to verify. It's in the verifying phase. Running component test. So we ran the component test, and this is the result. One plus one total. In here, in coverage, as I said, it will test all the code, including the uncovered line of code. So this is the estimate uncovered line of code that was not tested. 15 to 27 line lines. So from 15 to 27 lines. Test coverage. So how can you ensure that all code is called by test if possible? And how can you determine which code doesn't get called by test yet? The answer to this question is provided by special tools and determine the test coverage or code coverage. As a rule, the more code covered by tests, the better. So the more code covered by tests, the better. How does a function behave when it is called with invalid parameters? How does a function behave if one of the parameters or several parameters are not specified? How does a sum function behave when it is called with two negative numerical value? How does a division function behave when zero is passed as the divisor? How does representational state transfer based web service behave when an attempt is made to delete a resource multiple times? How does a web service behave when called with an invalid JavaScript object notation or JSON payload? So determining test coverage in JavaScript, npx yes, so that's what we had. In addition, test coverage creates a coverage directory here. So here are the test double setup exercise verify cleared out. The test double is like the interceptor for this. So we will now gonna use the spice stub and mock types of test doubles. Now the problem with dependencies. Let's suppose you want to test a class that is responsible for saving and loading data into the database. How should you run if the external dependency is not available? So this is what we're talking about. What if you don't have a way or an opportunity to apply your knowledge? So you're just reading the book. You don't have a computer that will allow you to run it from end to end, right? So which is unlikely, but just an example. So how would you do that? So just like we've discussed the spice. So here the problem with this is that it doesn't have dependencies. We're just checking it in isolation. So it's like it could be a good way, but it doesn't really provide us the real world test that we need to really push this into production. So let's consider testing the array method push in JavaScript as a simple example to check whether this method adds the pass element to the array. You would first call the method multiple times and use the length property of the array to check its length. So that's spice. You're not checking the external code that you've called. You're checking the length property of the array that you use to check its length because you're trying to just put an inspector to log what the construction worker have done. You're not really checking the outside, or you're not fabricating materials, or having a supervisor that will intercept the construction worker in case it doesn't work. So in this case, you can check the requirements for the component directly via property of the component, but it's not always that simple. Perhaps the object under test does not provide a property or method that can be used to check whether expected result, or perhaps the corresponding property or method is not publicly available. In such cases, we therefore speak of indirect output, that is, outputs that are generated internally by the components under test but are not made available externally. Suppose you have a component that internally calls a web service to retrieve the weather for a particular location and further uses cache. So the component would have two dependent on components, the weather web service and the cache. So there is dependent on components with the web service and the cache. So how would you test that using Spice? So if you want to run tests to ensure that the component really calls the web service only once and returns the data from the cache, you could determine this information by using two test files. So if you want to make sure that it only does it once, it only calls the web service and then returns the data from the cache, you would provide two test files, one for the web service, one for the cache. So one spy would simulate the weather web service and log number of calls, and another spy would simulate the cache and log the number of cache accesses. In the test itself, you would then only need to call the component under test two or more times and check the information logged by Spice after running the test. So the reason for this is when testing software, we usually test how often the software really integrate or calls another API or other softwares. So we really need to get to the nitty-gritty details of calling that API. Stubs. You can use these stubs to intercept certain indirect calls of the component under test to a dependent on component and return predefined values. So it's like a prefabricated material that returns the actual real-world simulation of creating a pyramid. This approach is useful when the result of a component under test depend on an indirect input by the dependent on component and you want to influence this input. In our example, you can implement a test tab for the weather web service so that component under test does not communicate with the real web service during the test, but instead communicate with the test tab. So note, basically, you're trying to not apply it to the actual database or real world database because it's gonna affect the environment. It could affect the customer's information, which is crucial. So we're just trying to prefabricate materials so that when we integrate it, we make sure that we're not affecting anything important on the system or anything that could break the system. Note, so while Spice intercept indirect output from the system under test, Stub provides the indirect input from the system under test. So that's its difference to Spice. Mac objects, the third type of test doubles are Mac objects or Macs for short. Using this special type of object, you can intercept the indirect output of the component under test similar to test Spice. Unlike test Spice, however, Mac objects themselves already perform checks on indirect outputs. So like a supervisor that immediately check the sequence if something was wrong in how the construction worker put the mortar, and if it noticed that it will affect the scaffolding or the long-term integrity of the pyramid, it will not, it will immediately stop the construction worker and correct it. So it's like a mock. The goal with the mock object is to ensure that the component under test use says the dependent on component correctly. With our weather web service example, a map object could be used to check whether the component to be tested calls the web service correctly. For example, whether it sets the correct headers or similar. So for nitty-gritty details, the way we do map is like checking if the component or the unit sends the correct header. So remember the header something or the body that we sent to the third-party API. So that's the goal of Mappets. Okay, so we're done with testing. We were able to discuss unit test, integration test, and end-to-end test, which is or the basics. It could be more than that, like compatibility test, performance test, security test. Um, but those are the basics. The foundation is the unit test. Before we integrate it to the pyramid, we make sure that isolated mortar will be able to connect properly to the pyramid. Because imagine a pyramid that's already been built. Okay, we're just trying to add something on it, just like a normal web application. You're not trying to build something from scratch, but you're trying to add something on one that's already built. So it's, before you add something, make sure you're trying to add something that actually will perform or will integrate to the dependencies. So that's the test double. Integration test is like it touched test double touch a little bit about that, but integration test is like trying to connect now different components, and then end-to-end test is like a real life test or a real user test, which we won't go further here because we don't have real life application. If you guys have that, you can try it. Okay, so again, thank you for watching and see you on the next video.